Hi, I'm going to discuss about VLSI Design Flow. First, you have to know about the applications of Design Flow, VLSI Design Flow. Using VLSI Design Flow, we can design the mobile chips, or else we can design and pen drives. We can design and computer chips. We can design the laptop chips, or else tablets. We can design and we can design the washing machines. You can use it in missile technologies. We can use it in micro ovens, drone technology. So everywhere, this process is used to design some chips. If you want to, if we are considered a mobile, so mobile is having all the components, that is processor. Internally, it is having. So if you take an mobile, so this I am assuming an mobile. It is an mobile. So internally it is having, that is RAM is there, random access memory, and ROM is there, read only memory, and ALU is there, arithmetic logic unit. Like this, all the standard cells are inside placed. So these cells are standard cells, or else chips are designed by using that is VLSI design flow. So consider one example. Here you can see this. Uh, First, we need you should have some idea. If you got or any idea, so then we can go for designing. So for that, so for your idea or else innovations. So what is an inputs? What is an outputs for that? What is an input, and that is the specifications. What is our required outputs? What is your required inputs? For example, I have an idea, a small idea, and just assume that we need to design an AND gate designing if we have. So then, so what are the input specifications? Means A and B are the inputs, and C is an output. So C is an output. And coming to here design, we should design an architecture for that. So for our as you consider, for our requirement, this is an our design architecture. So coming to the here fourth step, after design, we need to write a code for that, RTL code, register transfer level code. So we need to write, and after writing the code, we are going for verification, RTL code verification. So if you are executed without any errors, then you can go for synthesis here. So after synthesis, we can go for, that is physical designing process, the backend process. Backend process. So this process till this part, we can call it as till this part. This is front end process. Front end process. This is the front end, and then we can go for back end process. In back end, so we have, that is placement, and we have the placement and routing, and also that is floor planning. Of course, these are the static timing analysis and other design constraints are required. So we can see this. So in the front end process, in this block diagram, you can see this. This is an front end process, that is specifications. We need to mention architecture, then we can go for RTL designing, then verification for RTL. So of course here synthesis. If you are executed properly without any errors, you can go for the backend process. So here it is timing analysis, whether we are made we can meet the our required timing constraints or not. So then only they will go for physical design, and then here in backend process there are placement and routing, as well as floor plan is very important. If you consider uh, an and chip, one chip is having, so here I am assuming, so this is an floor plan. I am assuming this is an floor plan in backend process floor plan. So in this, what is the placements? The good placement will reduce the power consumption as well as the uh, size of the chip. This is RAM is here, I am assuming, and one processor if you take, and ROM is here, ROM is here, ROM, random read-only memory, and ALU is there here. So here very nearer to one another. The standard cells are very nearer. So if you take another floor plan for any other chip, another, I'm assuming this is another mobile. So this is an one mobile. Uh, I'm assuming this is Vivo and this is Samsung, Samsung mobile designing process if you are assumed. So then here I'm assuming this is an RAM and they are placed here and ROM is placed here because both the placements are not the same. AL is here. We can say this here. If you want to move the data from here to here, it requires more time and it may generate more heat. But here, even here also, it requires more power consumption and the timing also required more to travel the data. So here we can say this in Vivo technologies. So here size is reduced as well as the power consumption is reduced. So that finally the good floor plan or else good placement will reduce the power consumption as well as the speed. Speed will increase and here it will increase the speed and noise will get more heat will generate because it consumes more power. So this process after this placement and routing, this is an routing process. Good placement and good routing is the will reduce always the power consumption and it will increase the speed and reduce the chip size. So this process is called as that is backend process. You can say this everything placement on routing and after that placement on routing they will go for sign off process. STM means it is static timing analysis for other sign off checks whether we met our required constraints or not. So then they are going for final fabrication process after gate level verification. So after fabrication means final output physical design. So by using this after physical designing, so they can go for that is packaging and testing. So this is about VLSI design flow. Thank you. Thanks for watching.